Atomic radius is half the distance between two nuclei of identical atoms bonded together. Atomic radius decreases from left to right in a period because the atomic number increases from left to right but the number of energy levels stay the same. The electrons added are all in the same energy level. The nuclear charge increases from left to right in a period. The electrons are greatly attracted to the nuclei with a greater charge, therefore atom volumes decrease. Atomic radius increases from top to bottom in a group, because the number of energy levels increase by 1. Valence electrons are far away from the core of the atom. Core electrons shield the outer electrons. The core electron's force of attraction on the outer electrons decrease. Atomic volume increases, so atomic radius increases. Now, according to scienceanalogies.com, atomic size is like the growth rings of a tree. As you go down a vertical group in the periodic table, the trend is that the atomic radius increases as more energy levels are added on. This is similar to the observation that as a tree adds on growth rings, the stem becomes larger in radius.
Ionization energy. What is ionization energy? Ionization energy is basically the energy needed to remove electrons from an atom. A high ionization energy means that more energy is required to remove an electron from an atom, and vice versa with a low ionization energy. The formal definition for first ionization energy is the energy needed to remove the first valence electron from a neutral atom in the gaseous state. There are some factors that affect ionization energy. The first of these is the charge of the nucleus. The larger the nucleus, i.e. the more protons, the greater the effective nuclear charge, and so the greater the force of attraction the nucleus exerts on the electrons. Atomic radius. The greater the distance between the nucleus and the valence electrons, the smaller the force of attraction the nucleus exerts on the valence electrons. Electron shielding. There are fold energy levels that lie between the valence electrons and the nucleus. The valence electrons are repelled by the electrons in the inner energy levels. This then affects the nucleus's ability to attract the valence electrons. Repulsion of electrons in the same orbital. An electron pair with opposite spins still has a measure of repulsion on each other. This then affects the nucleus's ability to attract those electrons. The trends in ionization energy. Ionization energy will increase from left to right in a period. From left to right, there is an increase in atomic number, but the number of energy levels remain the same. This results in an increase in effective nuclear charge with 1 for the same number of energy levels. The increase in nuclear charge means that there is a stronger attraction exerted on the electrons. Therefore, more energy is required to remove the electrons. Ionization energy decreases from top to bottom in a group. With an increase in the atomic number, the atoms have more consecutively fold energy levels. The valence electrons from atom to atom occur in higher energy levels. The outer electrons are then further away from the nucleus and are partially shielded from the nucleus's attraction by the inner electrons, which lie in the inner energy levels. With an increase in atomic size, less energy is required for the valence electrons to be removed, and therefore ionization energy decreases from top to bottom.
What is electron negativity? Electron negativity is the amount of energy released when an electron is added to an atom. The scale for electron negativity is the Pauling scale, with the highest value being 4, which was given to fluorine. Electron negativity does not have a unit of measurement. The higher the atomic number equals more protons, making it more positive, giving the atom a stronger force of attraction. More energy levels equals more distance between the nucleus and the outermost valence electrons. In other words, electron shielding. Electron negativity increases from left to right in periods and decreases from top to bottom in groups.